Hello ladies and gentlemen, my name is Dmitry and welcome to the Diplav's channel. In today's video, we'll tell you what's new in our design bureau, how we're settling in, and how things are moving along here. So shall we get started? Let's begin, shall we, with a little introductory tour, so to speak, of what we've built and created here. Let's say, starting with this particular pond right in front of us. There used to be a small pond here, or rather just a simple ravine, but we modified it and constructed this kind of concrete retaining wall, which is set deep on piles for stability. Then down here, there's a geomembrane made of bentonite clay, and it's covered with a layer of soil to protect it and help it blend in with the environment. The pond fills up to this level right here. Right now it's drained, so the water comes up to this mark, creating a beautiful water mirror. Over there, as you can see, we are currently testing the fountain nozzles. They're working. Cold water from the well cools the building, and the fountain is running. The fountain's flow rate is several cubic meters, but we won't argue about the exact number for now. You'll see it in the next videos. The pond walls are reinforced with a kind of plastic mesh, a geogrid, and then filled with gravel with geotextile underneath. Everything here will be landscaped soon. The entrance area will be here, and over there is the car. There, the entrance area. The neighbor's place over there is beautiful. We won't be putting up fences around the parking lot. Instead, we've installed our own retractable bollards with a barrier. These are the kind you'll see in the next videos if you're interested. They're electric powered. Well, let's move on. Here, we've put in these flower beds as a way to separate the areas. We planted hydrangeas here and installed an automatic watering system. Because we started watering these flower beds, and the concrete isn't of the best quality, it started to soak through. Here we have a Polyurea application setup. We coated it with Polyurea tinted black. Overall, it all turned out quite nice. All right, let's keep going. Let's go, Maria, from the main entrance. Yes, there are still a few small finishing touches left on the exterior. I'll explain what's what now. On the lower level, we have a main gate entrance where a small delivery truck can easily drive in. Here we have, so to speak, the dirty workshop. So, ladies and gentlemen, we're on the first floor. This is, let's say, the dirty workshop. Right now I see a bunch of scooters here. What do we have here? We have a badass sandblasting chamber. Here, a sandblasting chamber with gloves. We use it often. Don't pay attention to the ventilation, I'm still testing it externally. This is a compressed air receiver. The compressor used to be here, but the noise got annoying, so we moved it to another basement. Here are all sorts of tables and so on. We've got a little wash station. There's this kind of washer for all sorts of parts. What? Well, I don't know yet. It's in demand. Things get cut, things get turned here. This is from Zitnevo. We moved and brought it with us. This is Vanya's hand-operated machine. Machines like this are found in those Kang vehicles. It's a pretty beat-up machine because it tends to break down quite a bit. Here's a little model of the machine. So this is our manual milling machine, which is commonly used for precision metalworking tasks. Velusi made it. Maybe he'll show the nameplate. We often rough out the workpieces on it before setting them up on the CNC, mainly because they can sometimes be a bit crooked or uneven. That's the kind of careful preparatory work it does for us. Then we have as follows the gantry machine, a 3-axis Chinese gantry with oil mist, the second advanced gantry machine. And over here we have some drill presses. There's also a saw here, and it actually cuts quite well, making it very useful for our work. So let's say, I don't know for sure if this is the first floor or the lower floor, but maybe you've seen before, we have a hydraulic lift that goes upstairs and leads directly to the main workshop area. Let's walk around a bit and show you the local area before it gets dark. This is the proper ventilated facade. Here it's finished with wooden planks and carefully painted. This is larch wood, which we coated ourselves after the price for siding went through the roof, so we decided to make our own siding instead. There will be a separate dedicated video about that process. It seems we've figured out the secret to protecting it from ultraviolet light, and we even did some tests on its durability. That's a whole separate topic in itself. Here, Mama Show, do you feel it? The heat from the warmed up facade, you can really feel it radiating. Just hold your hand up like this. It's really warm. Here we have clinker brick. I don't remember which manufacturer this is. It's made at our factory in Chelyabinsk. I like it. It's got that handmade look. All right, let's keep going. Here, that's what it's called. See, it has a stamp right here. So that's how you know what it's called. Yeah. Swiss quality. I don't really know, but the quality is definitely good and I like it a lot, you know? There's even a waiting list to buy it, which is quite something. Now, folks, let me talk about something unpleasant that really upset me after the winter. Basically, the concrete suppliers, to put it mildly, deceived us. It was supposed to be B25 concrete, that's what we ordered. But as you can see, after the winter, it's definitely not B25. So basically, this is just a real bummer. The area we had to concrete is huge, and all the concrete that was used for the surface turned out to be crap. Here, it even had heating. The sad part is that the slab here is 200 millimeters thick, but we've decided to probably do this. We'll cut off about 70 millimeters and pour it again. We've set up our rebar and we'll pour it with B60 concrete, with a polished finish. By the way, what would you advise? What do you think about this? You can't fix it in any way, you can't even lay asphalt on it because everything will crack. And the area is large and all concreted, it's just so frustrating. It's like this everywhere for us. This is how it fell apart in just one winter. We made this staircase ourselves, it's made of aluminum. We had a lot of profiles and painting to do. Why aluminum? Because the powder coating can peel off and I don't like rust stains. That's it. Well, we even have a cable for charging electric cars actually installed right here. Here's this little fence. We had to build a makeshift retaining wall because of the neighbors. Don't mind that it's uneven here. The ground was sliding and the formwork was complicated because the plot was shifting that way. The soil was here and on that side it reached up to here. You can maybe film the view from here. It's really beautiful. So folks, here we used what is called standing seam metal roofing. We bought the strip for it. It's either Finnish or Swedish and you can't get it anymore these days. It's quite thick and has a really beautiful striking color. We also bought a separate standing seam rolling machine and we rolled it ourselves. Of course, building like this is expensive, but you can do it once. If you want, you can do it this way too. Here we have the gate. These are the kind of gates used in cold storage facilities. Ours roll in like this. And they just roll in. Do people forget to close them? They let the cold out? Well, let's go. Here is our main entrance, so to speak. Oh. Here's the main entrance, our main entrance. The sign, we made it ourselves. There you go. So this is our main right here. Entrance. Here we have the small workshop. And here is the main workshop. It's a bit of a mess here right now. Over there you can see the overhead crane. The overhead crane, it's about 2 tons, I think. Here we have a beautifully remodeled. So next we have this, our smart system here. Kirill, he redid the electrical wiring. It runs just fine, so we decided to put these crazy wheels on it. As for the laser, we decided to enclose it. First of all, so people don't get blinded by the glare because it throws off a lot of debris. Now we're going to carefully cover it with polycarbonate, and there will also be a special film in certain areas. These are essentially curtains that help filter out infrared radiation, because with 1.5 kilowatts you can get quite a lot of glare. Right now they're setting it up and making adjustments here. I wanted to mention how we got this kind of floor. It was pretty troublesome, to be honest. It's been ground down, then polished with a diamond grinding machine and treated with lithium, a lithium-based impregnation. But at least it's practical. Yeah, it's both beautiful and cozy. Here we have... Here in the electrical room, the guys have now set up shop and are getting started. They're sitting, working, each one set up at their desks. It's a truly creative mess in there. Right here, we needed to harden some of the parts. We have this Soviet diamond hardness tester. This one right here. The hardness tester measures the hardness of metals. It has a diamond probe, and it demonstrates the material's hardness based on how much it indents the surface of the material. There's only a little bit of carrot in there. That's what they're like. It's not about the carrots. It's just some kind of... But it's nice to have things like this. It's a tester. That's it. All right, let's move on. Fire extinguisher? Yes, yeah. The fire extinguisher is serious just in case for safety and precautionary reasons. Because there have been all sorts of incidents. Yeah, these curtains, of course, need to be cleaned, but it's fine. I think they look okay. Thanks for not spreading out. Yeah, otherwise Kirill was trying to cut them. He really needed battery gaskets everywhere here. Let's move on to the next part now. Yeah, I'll actually go ahead and put on my slippers now. Here we have this pair of slippers. People often walk around in cozy and comfortable slippers at home. Well, yeah, or sometimes even in shoes. The guys are all working diligently to the music, following its rhythm. So here we have the electronics guys sitting here, and everything related to electricity and electronics. And we also work on prosthetics here. You've already seen our prosthetics in the videos. By the way, this is a prototype. This is a prototype of a mechanical prosthesis for riding a motorcycle, ATV, and so on, with a safety pin. So it holds like this, quite securely. This is exactly how firmly and steadily it stands in place. But if you put this pin on your other hand and you happen to fall, then you just pull it and it pops right out. For now, it's made out of plastic material. It's a prototype, so to speak, but soon it will be made of metal. I'll be testing it. Wow. So here in our workshop, we decided to create cheek parts for prosthetics. These ones you see here are milled from solid aluminum, right? Yeah, they take a long time to make, so we decided to switch and make them out of carbon fiber instead. Right now we're milling this part, and the mold we're using is specially shaped and custom made. This one is made from pre-preg material, so it's already shaped to fit the mold. We laid it out on this mold and sealed it in a vacuum bag for a precise fit. Gleb is handling all of that work. And here there's a room for electricians and electronics guys to work on their projects. There are a lot of different things and components here. Of course, it's a bit of a mess at the moment since we've taken some things apart for repairs and modifications, but honestly, it's not too bad. And over here in this corner, Vanya even has a DJ controller set up for music and fun. The painting is awesome. Show it, guys. So, Dmitry. That's not Dmitry. That's Saint Dmitry the Victorious, the renowned and celebrated figure, valiantly slays both laziness and illiteracy. No, actually, that's Saint Atlas, who is depicted as slaying the leather sack. All right, let's just go take a look at something over there. Oh, shall we? So, here is the break room. This is where people often drink tea and sometimes have cookies. Here they have a spot where you can sit and hang out. Yeah, a talking hub. And over here is a little changing room. The changing room, and over here we have a small, convenient little bathroom area, as well as a shower. They took out the sink for a short while since it wasn't working properly, so they removed it, but before long it'll be back. 6%, which is 6 out of every 100 in total. So here we have a doorway leading out to the little balcony. It's still not completely finished yet. As I mentioned, we put some concrete supports here, but everything needs to be re-poured. There will be a proper staircase here, a wide, big one. You can relax here. It's a little platform like this. Vanya is tinkering with the jackal. They're up to something shady. And
because why? Because engineers use dimensions that are outline based with different tolerances, but in the model they're all the same. And why are they different? Well, the tolerances are different. For example, we have a dimension. Along the contour, yes, here it's 13.4, 13.2 is drawn in the model, but the tolerances are different. Here we have minus 0.05, minus 0.15, and here it's minus 200. So since it's all done with one cutter in the jackal, we have to make adjustments. And what are we cutting this for? It's for prosthetics.
So Ivan, right now we currently have a trial batch of prosthetics in progress with 50 individual pieces that are being made, and Vanya is here working on this advanced lathe milling Haas CNC machine to manufacture them. What exactly are you doing at the moment?
What is this we have here? It was just here somewhere. Here it is. This is what we have here.
We're actually making this kind of thing, this kind of piece.
Drive bushing.
Drive bushing. Someone might say you could knock this out by hand in a second?
Well, hardly, not with these tolerances.
What are the tolerances here?
Well, for example, the inner hole actually has a minus 18 micron tolerance, which is quite precise. That means it has a 12 to minus 18 micron tolerance range. The outer diameter, on the other hand, is exactly 200. And the surface finish here is really good too.
Vanya, could you please show me once more what you showed earlier? That tiny little part we machined, if you could.
The biggest blanks, which are prepared during the roughing process. Here too, yeah.
And what material are you turning it from?
From 20th.
From 20 stock, you mean, if I understand correctly? Well then, if...
Here too, the tolerance for the inner diameter is 4 plus 1/100th of a millimeter, so it'll definitely need to be reamed to the correct size.
And what's this?
Well, that's some kind of little bushing, something like that.
There you go, just like that. Well done. That's it.
There's actually quite a lot of really nice looking stuff here, honestly.
Does it usually take long to machine?
No, most likely about a minute, but today my shortest cycle was just 7 seconds.
0.7 seconds?
7 seconds, the whole program cycle.
So, we need these kinds of parts for the prosthesis. Right now, 50 trial prostheses. Like these, look at this beauty, these are bronze ones.
Yeah, those two got stuck together.
So, as you can see, these are the various kinds of spare parts that we have here. The main thing is not to accidentally sniff them. Yeah. Vanya, hey, can you grab that bent piece of metal over there? Now, Vanya will tell us how the machine got wrecked. Do you know where it is? Vanya, why do you need that hose caliper?
I don't know. It's actually for measuring these little parts.
This is a hose caliper for measuring.
We should measure it just for fun. It's a shame this one doesn't have a scale, of course.
Go ahead, check it. Well, actually, you know... Yeah. Oh, film the car.
And we really need, you know, like a thumbnail like that. Oh.
Yeah. Come on. So what do they measure with that caliper?
Huh?
Huh? What are you supposed to measure with that caliper?
Well, for bigger measurements.
Oh, did they actually measure something here or what?
Why not? If it's some kind of 2 meter long axle, you know.
At least it's accurate. Yeah.
Why not?
Did I buy this somewhere or did you?
Yeah.
Oh, didn't you get the metal piece? Yeah.
Became expander.
Look, here is an engineer's real expander in action. Vanya, tell us how the manufacturing methods.
Well, that's when your concentration starts to fade.
And like Palic comes over and, starts talking to you. Yeah.
Starts talking. Yeah.
There should be something like this.
Yeah, that's basically what happened. I accidentally made a mistake, entered M00 instead of M01. Or rather the other way around, M01 instead of M00. And by accident. And the point was that it would come to a complete stop. It would cut off the part, and then you had to manually break it off, after which it would continue with the next steps. Centering, threading, drilling, and then you would pull it out, yeah. So the part would remain in place, there'd be a pause for the operator to break it off, and then it would continue and cut the internal thread. And accordingly, I turned off the optional stop function to streamline the process. There was an M01 and it went into that part, which was held by just 2 millimeters.
It hit tailstock.
No, with the center drilled, it actually tried to center itself through the whole part, began to center, and then...
The force from the tailstock was so strong, it really bent it.
No, let me clarify, that was the turret.
So we had to readjust the machine just a little bit.
Yeah, we broke it in, that's it.
We ran it, everything survived. I thought it was going to break. Vanya, tell us about the difficulties of turning this stainless steel. Is this for scooters, where the axle goes?
For scooters, this is the shock absorber axle. Well, stainless steel is hard to machine. This 0.8 X17T, it's not exactly stainless, it's a high alloy corrosion resistant steel. The point is, if you take regular stainless like 304, that's pretty common there. It's more ductile there, and you can hardly get any chip breaking at all. And that really complicates CNC work because you constantly have to open it up, remove the chips. They get tangled, sometimes even cut your fingers. It's all pretty unpleasant, honestly. But this steel chip breaking works well on it, though the tool still wears out quickly. So, for example, a finishing tool, not a roughing one, lasts for about 5 axes like that. And that's even at reduced speeds.
Also, as I understand it, you had to select the tapers because they get pushed out.
It gets pushed out naturally at the center. With CNC, that's good. You can compensate for everything in the software. Any deflections, tapers.
Yeah, so how many tries did it take to get the first part right?
It was about the 4th or 5th try.
Yeah, and then after that, so...
Here again, what happens is that the chuck actually ends up being noticeably stiffer and more rigid than the tailstock. And the thread here is specified with a taper of about 5/100ths. So it kind of cuts it like this because the tailstock pushes harder. Well, the center here is just a bit weak if, well...
In this one? Yeah, and what's...
Reduced.
I wanted to say, what's good about lathes with driven stations is that you can do these grooves in a single setup, actually. Well...
It gets more interesting on the...
axis. Yeah, bring the shaft. Let's take a look. Well, mamas, move over here. I mean, poke it. It's right behind you. Here, mamas, the shaft.
Here's a more interesting part. These are actually motor axles, specifically engine axles designed for a scooter. Here, both the coolant fluid enters directly through the axle itself, and the electrical wires are carefully routed inside, plus there's a hall sensor, keyways, and several holes for various purposes. So basically, an angled fitting is screwed in here, and there's a bore here about 110 millimeters deep, with a 4 millimeter diameter in stainless steel, if I remember correctly. Here's the keyway slot, and here accordingly is the hole for the wire feed through. Here we have a bearing, and here's a seal. Another bearing goes here, so this is the seat, meaning there's a wall here.
0.65. They bend it carefully and it still doesn't go in here.
Well, it was actually pretty tough to do, mainly because of course it's always better to order a special tool for this kind of job. But there's a carbide drill bit available there, and it costs about 12,000. And if you use some kind of extended carbide centering tool, which would really be the proper and most precise way to do it, it would be even more expensive. So what I did instead was just use a regular R6M5 drill bit. Just picked one that centered itself for me, first at a very, very low feed rate, and then I drilled it carefully.
Yeah, I wanted to ask, Vanya, when did you get the hang of this Haas? Not that long ago, right?
Yeah.
Been a month. 3 maybe?
Yeah, probably. I was away for a while too.
Well, yeah, honestly, you probably got the hang of it in about a month and started working on it actively. At first, everyone was kind of hesitant, but thanks to, well, we have Alexander here. Shout out to you, Sasha. A real professional when it comes to working with Haas machines. He kindly agreed to give us lessons for cheap as a friend, so at night the guys are really making some good progress. Now I feel like soon every operator here will be able to work on a Haas.
I would tweak the post-processor here.
Yes, that is to say everyone is right. At first everyone was afraid of CNC, few worked on it, but now everyone is doing great. I like that they don't arrange themselves. The repetition is good. Because, did anyone also say, yes, I was in hand-to-hand combat? There, 3 seconds. It can be done if someone is watching, but it takes a long time.
160 axes were made in 3 working days. 3 shifts of 8 hours each.
These axes, right?
160 pieces.
You think you have 160 pieces? Yeah, they're also within normal tolerances.
Yeah, the tolerance there is 0.02 millimeters.
I think. Oh, here they are, the little axles Rososiki. And what kind of axles are these? Are these the same?
These are the front wheel axles. These right here.
These are also perhaps made of stainless steel, like these.
Yes.
Vanya, what would you generally like to say about the Haas? What do you think?
It's a good machine. Overall, CNC is essentially a technology that's designed for serial production. Still, for some parts, especially during the setup process, writing the program can take 2 days while you figure out the settings and everything. Sometimes it can even take longer, like 3 days. The program setup and selecting the right parameters. So it's just not practical to do all that for just a couple of parts.
Yeah, but sometimes you really do have to actually. Yes!
And when it comes to fine-tuning, then it's really like there's a kind of gradual progression that happens over time. The more time and effort you spend on the initial setup, the faster and faster the parts will come out afterwards. So you can add things like bar feeders, part catchers, like today we installed an auto opening door. You can set it up so that...
Yeah, so folks, in theory, you could actually, in fact, even make a bar feeder that feeds material from the back. No, an extractor. Oh, an extractor. And you can add catches so it can do batch production.
Yeah. And then you could make these little parts, right? You load in a 1 meter bar, say D16 brass, turn it on, and in a couple of days it could make 1,000 parts without you even touching it.
But just out of curiosity, is the extractor expensive?
No, the extractor, the spring-loaded one, isn't expensive.
And it's just a catcher like a basket, right?
Yeah. The idea is that the chuck is clamped, it's spring-loaded, and it moves onto it tightly. So the chuck opens up and pulls it out because the spring compresses. Then the chuck clamps again and it pops out. That is, it works simply due to the spring, due to the fact that the chuck can be released and the cycle can be tight. Yeah.
Well, that's great. Well, everyone is asking how Vanka did it. That's it, Vanka is here. We just need to make a bunch of scooters now. We need to make an ATV. Titanoviki Bitki 2 will be back, I think. We're just getting settled in here now, back and forth. All right, then, let's go. So, I'd like to take a moment to introduce our new colleague, Alexei. He wrote to me by email mentioning that he wanted to change his life and his job. I gave his resume to Alexander, who's our main guy for scooters. He said, all right, let's take him, let him come and see. Tell us, how did this idea come to you?
Yeah, I've wanted to move for a long time. Well,
tell us, where are you from?
I'm from the city of Bulakovo, which is approximately 1,000 kilometers away from here. I wanted to find a job where I could create, basically to write programs myself, to make parts myself, and here I found it.
And what did you do before this?
Before this, I worked on a huge industrial machine, actually the biggest one in all of Europe. We made turbines for large hydroelectric power generation plants.
As Alexei and I used to say. It's all pretty epic, of course, but you just stand there for a long time watching it cut chips. You stand there and...
watch for a long time as it cuts chips, change the insert, remove the chips.
Well, yeah, just so you understand, machining a single turbine wheel can take like a month probably. Yeah, a month. So basically, you're working on something huge and cool, but it takes a really long time. And how much of that cool stuff do you actually make in your whole life? You might make 100 pieces, and that's it. How old are you, Alexei?
I'm 20.
Look at our young people. He really fit into the team actually really well, and mostly works on the 5-axis machine. What can you say about our machine, the Haas? Yeah, what got you interested? Let's put it this way. What interested you? What made you want to work here?
I really like writing computer programs myself because I do absolutely everything on my own. I think for myself, I make all the decisions, and I do it exactly the way I want. I'm not dependent on anyone else at all. And that's the most important thing in work, freedom.
The freedom to be creative.
No matter what anyone says, I still believe that being a machine operator is a creative profession where you need to know how to create. That's what interested me about it.
So, what can you say about this machine? Is it a good one?
We carefully pressed the button to clamp it securely. When working with the mold, it was really tricky not to hit the limit switches.
Yeah, that's true. So, what are we cutting right now?
We're cutting, by the way, this is the first part. I just started it, running it in and watching how it goes. The front part of the deck,
Yeah, that's the deck from a scooter.
the scooter deck, right? This is just the very first program right now. I'm optimizing it now based on the experience from the previous part. Processes very short lead-ins and lead-outs, so everything gets done quickly.
Yeah, that's true. By the way, gentlemen, we've reached the point where for some parts, when we're making the 10th one or so, we just leave it running overnight. It's really, really scary, but you want to do it because each part takes 2 or 3 hours to machine, and you want to get at least one more done in a day.
Well, for example, this one should only take about an hour to machine.
Yeah. And this coolant feed through the spindle is really,
You could say it's my own development.
because we've never used, oh, you just run it through the collet. Yeah, yeah. So even though it's not hollow, it just pushes through.
Yeah.
Yeah. We were surprised here, like, why isn't the coolant running through this one? Now he'll
Turn it on.
So the drill has no holes, but we just run it through the collet. Yeah, it's very,
That is good.
and it clears the chips better.
Well, here's the machining, for example, of pockets, which are narrow. The outer one doesn't clear the chips, but through the collet it clears them perfectly.
Even though that's not really how it's supposed to work, at least in theory, it still somehow manages to reach and cover all the gaps.
That's actually what it was originally made for, and only later did they come up with the idea to make a hole.
There was a very powerful pump here, like a high pressure one. It gives it a boost.
Blast out.
Yeah, and it shoots it right out of the cut. That's how it works, and it looks really nice. I'm always mesmerized by it. Look, you can just stick all of these in.
Yeah, you can stick them in. It's especially interesting when the table spins. It's really
When it moves simultaneously in all axes in every direction.
full 5-axis machining is definitely more interesting, of course.
Well, I'll say this. We break tools less and less often now. The guys get so worried, but I tell them the main thing is not to wreck the machine. If you break something, it's okay, really.
It's terrible. The tool isn't as important as the machine itself.
Sometimes you just have to keep that in mind. Sometimes things break. We often use a lot of cutters, even ones from AliExpress. And honestly, they work fine. They're not bad tools. Yeah, they last just fine.
They've already learned how to make them.
Of course. So when you use them with coolant, as far as I understand, they last a long time, right?
Yes. Yeah.
If you don't violate the settings, everything's fine.
Well, for aluminum, these cutters last forever if you use them like this.
Wonderful. Hey, let's go ahead and show your wonderful creation. Yeah, I actually do it this way myself too. So, folks, we have a really interesting project here. We haven't told you about it yet, but we'll definitely show it to you a little bit later on. So just stay tuned. This is a boat, specifically a motorboat that features a track drive, which is somewhat similar to a snowmobile, allowing it to travel in shallow water. Renat, who is a friend of ours, is working on it. He lives in Kazan, a city with plenty of water, and that's exactly where he's developing this project. He calculated the blade profile for the tracks because regular snowmobile ones don't fit. So we designed the profile for casting. That took half a year or even a year. There were so many headaches involved. There was cavitation and so on. We calculated the blade profile, and we're going to cast the blades out of polyurethane and attach them to a smooth track for testing. For this from, I think it was D16T. We made it from a piece of that. That was the mold for casting. This was our first experience like this, but it turned out pretty well, it seems. Tell us about the difficulties and so on.
The main difficulty we encountered was in carefully machining this particular surface. Since it's actually quite deep, we ultimately decided to split the mold into 2 separate parts to make the process more manageable. I just drew a line in the program, divided it into 2 parts right along the contour, and then carefully machined each part separately. I added alignment bolts, and everything fit together perfectly. It looks nice.
And this part, it's all on top, right?
This one can be placed on top here. In principle, it has some weight to it.
So we ended up with this pretty intense and detailed casting mold. The accuracy is actually quite good, but this blank area here is probably as much as possible. Coins.
I turned it off.
So we went ahead and made this casting mold, which was actually our very first experience doing something like this. Well, I think that with this mold, we'll be able to cast a lot of polyurethane paddles for the tracks, and it should work quite well for that purpose. We made it with the sprue right here, as you can see. And this is actually the largest part that I think will fit into the Haas machine along this particular axis.
Along the y-axis, yes, it went right up to the end stop. Its length is specifically 480. 500 is the maximum, plus the tool diameter so it can clear the part.
And I really liked, guys, how much you made it in about 5 days, right?
Yes, we did everything.
Yeah, so basically from the moment the task was given, the point is some guys were modeling the ANSI profile, right? That's a program for simulating all sorts of physical phenomena. It was a really long job because it's not just for show here, it's to ensure minimal cavitation and other things like that. Then they made a 3D model of it, and it actually appeared in metal. I remember how it was tested here. Everything went well, nothing broke off.
One day, one part, the next day, another, the third day, and so on, yes.
So if someone needs us to make something like this, it's expensive but fast, we can do it very expensively. I mean, not very expensively, but very quickly. Fast and high quality, but expensive. Because right now, all our machines are fully booked, and we don't really take on many commercial orders. But if someone really needs something, our team is very creative. They can come up with any crazy idea. So I'd also like to show this little part from a scooter. I really like it. It's from Petya, and Yakurova flies with it.
Through this, as a result.
It takes 2.5 hours to make one of these, right?
Yeah, well, about that.
For the work involved in this process, we've also made quite a lot of these here already. Here are some of the parts of the display that are already prepared. The top cover as well as the bottom cover. This is how the assembly will look. So we buy aluminum plates and carefully grind them down into shavings.
We produce shavings.
Yes, we produce shavings. At least we found somewhere to sell the shavings. So we sell these shavings and the money goes into the cookie fund for the guys, not to someone else.
Cookies, coffee, sugar.
Yeah, cookies, coffee, sugar. So there's enough for cookies, coffee, and sugar, plenty. Can you do pull-ups? We'll say that only athletic people work here. Yeah, how many pull-ups can you do? Hold on, but Lyoko will do better with the punching bag.
So, team?
All right, let's take turns. Oh yeah, go ahead and film it. Here at Deep Labs, we're really into sports, healthy living and all that.
Yeah, right.
I'm always trying to get people to quit smoking, drinking, and so on. Basically, today we have only non-drinkers. That's how it is.
We don't take soft food.
Here we have, gentlemen, a hand washing station so people can properly wash their hands right here for everyone. So that's how it is. All of this design was thought up by Anatoly. We even have this cute little lighting and this cute high-tech trash can. Right here, yes, as you can see, all the dirty plates are stacked. This is where the food is served from. Look, what's for dinner today? Let me see. Plates?
With freshly chopped, tender and juicy chicken.
And there's even a fresh, colorful salad here, I see. Everything, as always, is absolutely delicious.
My hair is always done and styled and always looks neat.
Yes, yes, absolutely, yes. Lots and lots of delicious meat. Very big portions, definitely, yes. We have an exit to the street. We were thinking maybe we could put some tables here. Tolyan, maybe we could put some tables here so we could have coffee since we built it, but we're not actually making use of it. Damn, Anatoly got pulled away from his food because of our filming, but it's okay. By the way, Anatoly, I wanted to mention, he's our and Maria's workout coach. He does both fitness and weightlifting. Yes.
He works out.
Yes, yes, yes. He really does support Maria and me, and he basically keeps us in good shape, you know?
Dima will be benching 100 soon. Check it out on the channel. But I think there's not enough space for tables.
Well, we could put one table. Put some poofs. That would be better.
Or something like little cushions, so people could bring them in.
Yeah, and just sit here. Maybe put small tables so you could have tea. Well, the windowsill.
On the edge. Can you hear your Pavliks, perhaps right now?
Pavliks, yes. Gentlemen, I want to talk about the technology here. I've always been an advocate for Bochinin's field. Why? Even Anatoly will tell you, no matter what kind of waterproofing you do, even the coating type, it still starts to leak. Somewhere around here, it started leaking in some corner, and it wasn't clear which one. We tried hosing it down and all, so I decided to just rip it out. We have our own setup for spraying Polyurea. We sprayed everything with Polyurea. Now I'm sure this will last 1,000 years because it kind of coats everything as a single monolithic layer. After that, we laid the tiles because that's a brush-on waterproofing material. You'll always miss a spot somewhere. This corner here started leaking for us. And basically, it's easier to just redo it and forget about it. That's how it is. Yeah.
Now this problem won't bother us anymore?
Yeah. Never again. Well, there are some nuances here. We opened KBN on January 19th, 2020. There are some flaws, but we're working them out slowly but surely.
It used to flood the whole place, well, like it did last year, so Dmitry decided to just take everything and fix it beyond the field.
And now, as everyone saw, there were some heavy rains. Everything is dry here.
Yeah, everything's fine. From now on, everywhere I go, flat roofs and so on. Only polyurea. It might seem relatively expensive, okay, but you can apply it even on unprepared concrete. Just knock off the cement latents, give it a quick polish, apply the polyurea, and it will last for ages. That's much better than having to redo repairs later, dealing with leaks and so on. Here's an interesting nuance. Right now it's just a cafeteria, but the goal was to make it so that people would genuinely want to come here. The building itself is quite interesting, so we wanted to create something more like a restaurant. Lenny, take a look at what we ended up with. Let us know in the comments if you like it or if you have any thoughts to share. We truly did our very best. Yes, everyone is eating and everyone just likes it.
Let's just say that, well, there will definitely be one, that's for sure. Kirill, as always, will be there, as usual.
On the shoot, come on, let's show the inside. Maria, this is our gift. Oh, right, okay, show it. Anatoly gave this to Maria and me for our wedding.
The statue is called Fusion.
Yes. Well, it's a little off in terms of height. Maria is a bit taller, but overall, you're already merging with them. Yes, I'm posing with them now. But this is art, it's abstract. No one said it would be an exact match. That's right, that's how it is. The gifts came with you, we'll move it from here. Why is it standing here in our restaurant?
For now, it's decorating the restaurant, Masha, and it looks great, since we spend most of our time here.
Yes. So let's show Masha the inside.
Of the kitchen area.
First of all, it's a bit odd. Can you even see anything in there?
Film the whole thing, it's a bit messy. Just like that, yes. That's our kitchen area. But we also want to put a freezer here now and move the second display case into the fridge. There's not enough space. We use an induction stove. I really liked it actually. So, well, this is now right here. As you can see, let me show you. We have in fact a high-speed dishwasher, which is really quite impressive. They also promised to buy potatoes and a peeler because it's tough without them. This is Maria, our head chef here. And this is her assistant. What is your name, if you do not mind? Sorry?
Vasila.
She manages well. 64 people are being fed. It's tough, but she seems to keep up with everything.
More now.
Yes. By the
Window.
Well, Tolya, whoa. That's exactly what you need to achieve in order to succeed. Not really just yet.
No, well, let me see. In general,
Everything. And you?
Reproduction. This is reproduction, and this is also, in fact, considered to be a form of reproduction.
Add Valera to the list. Yeah? Valera, with some minor accents.
we call him Valera Printer because he really, truly, genuinely does.
Understands the tasks.
And he adds to it thoughtfully. And he adds a little extra flair, a touch of his own style. Yes, the design.
There are no issues with him. All the artistic design, these reproductions here, Valery drew them. The stuff that's in the rooms, everywhere. Everywhere. He really draws like a mad printer. He just looks and draws. Good job, good job. He even drew with a broken arm. Somehow, somewhere, he broke his right arm.
These walkthroughs are also gold. Valera did all of this too.
Yes. Thank you, Valera. Greetings to you and creative success. We haven't seen you in a while. We'll drop by somewhere again, so don't get discouraged over there. Don't leave. He locked himself in here for 2 months, and that was it. Just walked around making art. What's up? Why isn't this work? Why not push yourself?